Hello, everyone, and thank you for joining us for today's office hours. I'm Haley Matisow, and I'm here with Dr. Jesus Puente, this week's product expert. Throughout the next 20 minutes or so, Jesus will be taking you through a live demo on external code integration in big data environments, as well as taking any questions that you may have submitted through Twitter with the hashtag RapidMinerOH. After the live demo, we'll be addressing your questions, so feel free to submit them through the Twitter feed, and you'll be able to see the questions at the bottom of the RapidMiner Office Hours page. So now I'll pass it over to Jesus.
Well, hello and welcome to this office hours. Thank you for attending and greetings from Madrid. So I chose this topic of code integration because I think that many people still have the idea that R, for example, or even Python and RapidMiner are competitors somehow because we do certain similar things. But I think it's totally the opposite, because we both come from the open source world, and we both have huge communities. We have hundreds of thousands of active users developing different extensions in the case of RapidMiner, or libraries in the case of R. And in maybe each community can focus on different things. So wouldn't it be great if we could take the best of both worlds, especially taking into account that RapidMiner is really more than a language. It's a full platform where you can also prepare the data, you can also operationalize, you have this security layer and so on. So well, we can do it, and it's great. So that's what I wanted to show you today. So let me share my screen, and I think you can see it now. Okay, so this is RapidMiner Studio, and what I'm going to show you is how you can.
We can't see your screen. I apologize.
You can't. Sorry. Now, I think you can see it now, right? Okay, so I was saying what I wanted to show is an example of how we can integrate this kind of code, of Python code or R code, within a RapidMiner process. The way to do it is these are extensions that you can find in the marketplace. So, for example, here, if I go to the top downloads, we can see popular downloads from our marketplace, and we can see that some of them are the R scripting and the Python scripting. Once you download it, you can find these operators, execute R and execute Python, where you can add this kind of code. One thing to take into account is that we really use standard Python and standard R distributions. So you could even have different distributions installed within your system, and by going here and setting the preferences, for example, in R scripting, I can select exactly the distribution, in this case a 322, I'm going to work with, right? So going to the example that I've prepared, I have prepared this example, this process, where I have taken some data, and I'll show what it is right now. I multiply it. That means that I'm creating 3 copies of the data, and I'll be processing it in 3 ways. One using the R process, one using a Python code, and then the other using just RapidMiner's own operators. And because I have parallelized the main process, these 3 things will happen at the same time. Before looking into each of the processes, let me show you a bit of the data. The example that I've chosen is a simple churn data based on a telco example, where I can see different telco users and the duration of their calls, international calls, how much they have spent in the last months, well, some more information, and then information from last year, whether they were loyal to the company or they abandoned it. So the idea of the processes that I'm going to see and to describe next is to be able to extract this kind of behavior and be able then to predict from new data what the behavior of certain other clients will be. Right. So going back to the design, I'll explain these three processes, starting with R. And as usual, the first step is to prepare the data. And in this case, what I'm doing is basically adapting the types of the attributes to exactly what the R library that I'm going to use will need. And this R library is, in this case, a logistic regression. The second thing is training the model is important, but it is very important to validate it. So to calculate the accuracy, how good this model is. So I'm using this validation operator. This is RapidMiner's operator. So if I see this little sign here, it means that there are sub-processes here. So I'll drill down. So within the validation, I have like two separate panes. One is the training side and one is the testing side, because what I'm doing with this validation is split the data into two parts. One will be used for the training and the other will be used just to calculate how good this model is predicting the data. This is very important because in this way we are going to test the data with, test the model with data that the model has never seen. It has not been trained with that data. So we are avoiding all kinds of statistical bias and so on. So I'm training here and I'm using this R means that I have some R code here. I can take a look. It's very simple in this case. I'm just using this logistic regression with GLM library. I'm getting the data and returning the model. And one thing that I want to remark and I want you to pay attention to is really the way we get the data and pass it from and to this model. So I'm just drawing this line and drawing this line, and the data that comes here is passed onto the library, and the result is going to be passed to the next operator the same way. Also, the apply model is based on an R code, also very simple. In this case, I'm predicting using the model and I'm returning data. And in this case, I'm getting two different inputs. One is the model and one is the data. But same as before, what I'm doing is just drawing these two connections, the model and the data. And as simple as that, I'm passing the data from my previous operator to this one, and the output is passed on to the next one, which in this case is just a pure RapidMiner operator. So data from RapidMiner to R and back is this movement is very easy. Post preparation is also basically changing some attributes to make them easy to read from by our performance operator. And well, this is our standard performance operator that calculates the accuracy. In this case, this is just some basic accuracy, meaning how often the model has been right as opposed to being wrong. But I could have tried to calculate, for example, the area under the curve and other more sophisticated measurements of performance. Once I do this validation, I apply the model, and there is a difference between what I found inside and outside. Inside, I was applying the model to only the test data. In this case, I'm applying it to the whole thing. So this is basically the scoring part of the process. In a real life process, these two parts would be probably two different processes, but I want to make everything all together here to make it simpler. some post-preparation, and then performance. So this is the way we would do a full R process. As you can see, and it's very interesting, we are making use of both RapidMiner operators and R code, which is very good because whenever I am inserting an R code here, I am endowing it with all the other capabilities that come with RapidMiner's platform. I can use this data preparation, I can enrich it with text or other non-traditional data sources like web, like social media, then go back to the R code, go back and transform it again, mix everything together, do this validation, and then all with the security, all these repositories that come with a server, the operationalization capabilities, and all that. So it's really interesting. This was R. Let's go to the next one, which, well, let's make it Python. And with Python, I'm doing something very similar. Data preparation. In this case, it's very simple because it's the model is accepting directly this kind of data, and then these two are the operators for the Python scripting. So, for example, here is the training. Let me show you the Python script. It's very simple. I have wanted to really make it as simple as possible. And in this case, I'm using a decision tree, right? So this is what I'm doing. And as you can see, and as before, let me show it again. I'm getting the data and I'm returning, in this case, a model. And as before, I'm just connecting one line and passing the data, in this case the model, to the apply model script, which, as before, uses model and data and returns data. So even if we have two inputs or two or more outputs, this is possible, and this is very, very simple, basically automatic. One thing with Python is you can use the standard framework. You can use the pandas framework for data handling, which is even more often used. So all those things are possible. Post-preparation as before, and then performance. I have changed the name to show that this is performance for R and for Python, but in fact, the operator is the same, is the standard RapidMiner operator for performance. This is the part of Python, and then just let's review how it would be with RapidMiner. And it's basically the three same steps. Data preparation, very similar. And then for the model training, I have decided to use this voting modeling, which is, as you can see here, it has sub-processes inside. So let me drill down. This is the process, and this voting model is really a combination of several, in this case, these three models, two differently configured logistic regressions, and one optimized tree. The way this voting model works is that it will train the three models with the same data, and then when it comes to the scoring, to applying this model to a single row, for example, then it will use the three of them, and if the three agree, then the solution is obviously that one. If two of them say something and the other one says the opposite, then the majority vote will be used. You can use 3, you can use 5, or whatever number that you prefer. So why would you want to do this? This is interesting, especially if you have very heterogeneous data where, for example, you have some kind of outliers and you want to keep them, but maybe some model is better at predicting that, and rather than the standard model. So you can use it in that kind of situation. Also, this is an optimized tree, but in fact, this is really our optimization operator. And again, you see this symbol here because I can drill down And here is where I actually see the decision tree. So this is not really a random forest. This is just one tree. And here, by the way, I would like to show, to take advantage and show how we help a lot in guiding the development of any process. You can see here the recommended operators. For example, it's also recommending me to use, well, you're trying logistic regression and decision tree, why not a neural network? I have also some text help here with tutorial processes. I have some help related to every one of these arguments. And then it's very interesting because of the optimization that I have this here help from our community. This is what we call the wisdom of crowds. And here we can see that 75% of the population of the community is using gain ratio as criterion. And more interestingly, in this case, which is numerical parameter, people are using something between 20 and 29. So what I'm doing with this optimized tree, let me go back, is selecting, I can select any of the parameters inside this operator, in this case the maximal depth, and I am telling it to try all these possibilities. So because in most cases getting the right model for a data set is something like an experimental thing. It's trial and error. It's a good thing to have an automatic way to decide which parameters are best. So in this case, when I run this process, and well, after that I will just apply and create the performance. Let me run it. It will take something like a minute. When I run this operator, what it's doing is it is training both logistic regression models, and it is also training all this decision tree in several ways, using different parameters, getting the optimal way, and then merging all and creating all with the three models. Let's say a merged model of that. Then it's going to apply it. Here in the R validation, it's also running several times because it's splitting the data in different ways. That's why, for example, the Python, which has been the simplest process, has already finished. And if we're curious, we could already see the results. But let me wait for the end. This is the final result. This will be, well, in fact, we have three different results. The Python one, the R one, and this is RapidMiner. We have also this confidences, this statistical confidence. In this case, it's quite a simple model, so it's 100% or 0. And we can also get the performance. So I can get, for example, for Python, 93% with false positives and false negatives. And this is very important because I can have an idea of how good this model is and can I put it into production or not. I can see R, which is slightly better, 94%. And with RapidMiner, it's 100%. It's not really 100%, or the performances are not different really because one is R and one is RapidMiner and the other is Python, because all these libraries, all these algorithms are really standard. But because I have been able in one case to apply this validation, in this case to apply this optimization, so I wanted to do this in order to show how also this code could benefit from this kind of optimization, validation, and so on. So that's the way you can integrate this code into any process and make it available then for operationalization, industrialization, and so on. And I also wanted to show something else just to end, which is that we can also do this in a big data, in a Hadoop environment. The way to do this is by using our Hadoop connection. So in this case, for example, I'm getting same kind of data, and I am here connected to my Hortonworks environment, which in this case is, I'll show, this is my my sandbox, right? So if I get inside, again, this has a process, and I have something similar to it. Let me run it just because it takes some time. I'm doing basically the same as before, preparing the data, running, in this case, a Spark script, which is R. I could have done it in Python. In this case, I'm getting this model and returning the prediction directly. So I'm doing the training and the application of the model in with the same code, and then I'll do some post-processing and performance. And all this can be done, as you can see, very transparently. And the huge advantage of all this is, well, if you know Hadoop is not really a technology, is like a family of technologies. You've got, of course, Hadoop and Hive for data access, but you also have the direct HDFS. You have Spark, you have the Mahout libraries, you have big scripting, Yarn for task distribution. You have lots of different technologies. It's really difficult to try to create a code in R, for example, and try to distribute it there. And we can do all that also with the data preparation, with all the steps before and after. Just as you can see, just by clicking and creating these four boxes and connected them. And so if I, for example, connect to my, let me see if I go here to my Hortonworks environment, and I refresh, I can see all these different tasks that I'm doing. Some are MapReduce, some are Spark. Hive does not appear here, but there should be something running also. And I can see how they are parallelized. In this case, it's just a single node, but I have two containers and both are running. And I can see how we, here in this case, RapidMiner is basically acting as a kind of technology integrator. So we provide a lot of the algorithms, but we essentially make use of Mahout libraries, as I said, Spark libraries, Spark scripting, Hive scripts, and so on and so forth. This is basically it. I'll leave it like I leave it here, and we can go back to Haley and see if there are any questions.
Great, thanks Jesus for sharing that with everybody. As a reminder, you can enter any questions in the Twitter feed with the hashtag RapidMinerOH. But I do have a couple follow-up questions for you, Jesus, and I'll go ahead and ask you those now. So the first one is, how does this integration help in the operationalization of R code?
Well, this is very, very interesting, and I want to insist on it because I think it's one of the values that we bring. You can have the best code and you can have the best developers. If that data does not go to the right hands, does not appear in your CRM, or you create an alert, or someone receives really this information, it's completely useless. So by inserting this code into a RapidMiner process, it's very it immediately becomes available. So you can integrate by using our web services. It can be integrated in a BI solution like Qlik or like Tableau. It can be integrated in a CRM in your Salesforce, for example, to if there is the end result of this process is, for example, something like a marketing campaign. So it's really, I think this is one of the keys. Yeah.
Great, thanks. One more question. So can I use any package and R distribution?
Yes. In fact, as I've showed at the beginning, what we are doing is we don't have really an R distribution or an R engine, an R runtime. We use the standard R, and that's it. If you have your standard R and you can add any package that you install there, then it's okay. We are just passing the script, the code to the runtime and get the results back. In fact, the only requirement that we have is that the package called data table is installed, because that's the way we communicate to the runtime, and we send the data and get the results back. But that's the only thing. That's it. So we can do that.
Great, thanks. I don't see any additional questions, so thanks again, everyone, for joining us for today's office hours, and feel free to join us next week as well. And everyone have a great day.